Hi, I'm Veda, and I'm part of Group 4. And this semester, I worked with Caroline, Monica, and Connor on StepForward. So the whole concept of our product was to create insoles for blind people in order to allow them to walk from destination A to destination B. The whole idea was to use vibration motors on their insoles in order to allow these vibrations to tell them which direction to go. So we used haptic feedback or vibrations instead of an auditory cue because a lot of blind people rely on their sense of hearing, and so we wanted to step away from that sense and allow them to use that sense when they are walking, and to give them that independence to talk to their friends or listen to music while they are walking from destination A to destination B. So on the market, there's already one insole that's created for runners. However, ours is very unique in that it's for blind people and it's very reliant on vibrations. So the solution to the problem is StepForward, which is two insoles with vibration motors on them. So as you can see, these two insoles have these two vibration motors, and we place them on these specific locations of the insole so that it's the least intrusive on the user while they walk. The next portion or feature of the insoles was the accelerometer. We only use the y-axis orientation of the accelerometer because we want the user to be able to tap their foot and send an input to the code or to the software, and then from there an output is given to the user where it tells them their current location through the GPS sensor. So the GPS sensor is located over here on the circuit board. It acquires the current location of the user and compares it to the final destination in order to see where the user should turn left or right. So going back to the vibration motors, once a turn is detected, if the user needs to turn left, the vibration motors on the left insole will start vibrating, indicating a left turn. Same thing on the right side. So at the moment, our prototype has a lot of wires, and we hope to make this wireless in the future using a Bluetooth adaptation.
So I'm going to be describing our StepForward main VI and its operation. This VI in the front panel is what the user is principally going to be interacting with, and it's a little rough right now, but that was due to some of the limitations we encountered on our project. But so on the left-hand side, we have these two numeric controls, which are the destination latitude and longitude values that the user will enter at the beginning. Right now they're set to 0, 0, which is somewhere in the middle of the ocean. And on the right-hand side, we also have this user requested information string, which displays the current user input state, and it can be updated to display your current latitude and longitude when the user taps their heel really hard. Now I'm going to show you guys an example of user input when they tap their heel. So if you come close, you can see the current latitude and longitude coordinates displayed, and in our actual program, the end goal would be to have an auditory cue give the user their precise location so that they know where they are, but they only get an auditory cue when they desire it. So now I'm going to show you guys an example turn route and how the program reacts as the user progresses down a route. When they reach the GPS turn coordinates, the insoles, the vibration motors in them, will vibrate to indicate them to turn left or right. So I'm going to input the first latitude and longitude coordinates of the first turn, which are at 2031 and 28978, and then the left vibration motor is going to vibrate, which it is doing now very faintly, and it continues to vibrate so long as you are still in the turn coordinate because we have not yet moved out of it. So now if I put in the destination coordinates, both will vibrate. 2143, and the Boolean has lit up to show that the user has reached their destination, and both of the vibration motors are vibrating now. Overall, we're really satisfied with how far we got with our project. We ran into some obstacles incorporating mapping and sort of routing with Google Maps in LabVIEW. That was kind of difficult, but we are hoping to, in the future, be able to incorporate that into our product. We're also hoping to incorporate text to sound communication so that the app is truly auditory in receiving commands from the user for their destination, and also outputting their current location when the user gives them input. And then we're also hoping to incorporate Bluetooth to make it wireless, because right now there's a lot of wires, but in sort of the insole application is not very feasible. But we are very proud with how far we got. We felt like we made a product and we demonstrated some functionality with our validation tests, and that we made it some decent amount of the way towards market realization. We would like to thank Dr. Merrick, Yuhao, and Mingyu for all their help in lab, and also our classmates for all their support.